internal energy. This is called U. And in our first law energy balance, we typically are going to have some big energies like the kinetic energy and the potential energy, the heat energy and the work energy, and the internal energy of the system. And the internal energy of the system refers to many different types of energy that a substance can inherently have at any given time. Some of it has to do with heat. So measurable temperature changes. The sensible energy is a portion of that internal energy of a system associated with the kinetic energies of the molecules. As you put more heat into a system, they are going to have more motion and they are going to have higher temperature. Or yes, higher temperature. So increased motion means increased temperature of, and then that temperature can be exploited or used to do work or to heat something, etc. All right, then there's a thing called latent energy. Well, the latent energy is the energy that is associated with phase change. The thermometer no longer goes up as more latent energy goes into your system. The thermometer doesn't go down either, but as latent energy goes into or out of a system, a phase change exists, and that's pretty handy as well. So this is solid to liquid or liquid to gas, and in some cases, solid to gas. Chemical energy is the internal energy associated with the chemical bonds of a molecule. This chemical energy we can be exothermic or endothermic. Whether it releases heat or it absorbs heat in the form of, or it absorbs or releases energy in the form of heat is exothermic or endothermic reactions is another way that internal energy is can be exploited to be converted to other forms of energy that are useful for whatever we are designing. Nuclear energy is the energy associated with the strong bonds within the nucleus of an atom. And that nuclear energy can be converted to heat as well. Heat and also to kinetic energy, the energy of motion or the energy of velocity. And in that case, tends to do damage. In the case of heat, tends to help heat up steam really nicely to drive a turbine in order to create energy. So here's are just some symbols of the microscopic forms of energy. And the sum of all of these energies is the internal energy of a system. So the internal energy of your system is the sum of all of the above mentioned energies: sensible, latent, chemical, nuclear. So when we add up all of these, then we get the internal energy of a system. Very useful to exploit to do work.